Good afternoon, students. Welcome back once again to the mathematics class. The last lecture we have seen how to find the area under the curves and area under the curve and the line, and next area between two curves, right? So area between two curves we have discussed in the last class. So now we are moving towards the exercise 8.2. In that first example, that is nothing but find the area of a circle x 4x square plus 4y square equals to 9, which is interior to the parabola, that is x square equals to 4y. So the required area, let's see. Solution already this type of problem we have discussed in the introduction class, last class only. So there just we have discussed the parabola is y square equals to 4x, it is right. It is y square equals to what? 4x. But here x square equals to 4y is there, right? So let's see. The required area is represented by the shaded region A, B, C, D, O. Already you know how to plot the graph. So let's we are taking here 4x square plus 4y square equals to 9 means what we have here? We have the radius. The origin is 0, 0 and the radius r equals to what? We have 3 by 2. The radius r equals to. So just here you can take 4x square plus 4y square equals to 9 by taking 4 common. X square plus y square equals to 9, x square plus y square equals to 9 by 4. So after all, x square plus y square, which is equals to 3 by 2 whole square, right? So the value of r is what? The radius is 3 by 2, that is 1.5. At the distance of 1.2, that is center point of a radius, we have taken a circle, and the parabola, that is x square equals to 4y, it is 90 degree towards the right side. So now we have to find the point of intersection by simplifying circle equation and as well as parabola, that is just substitute 4 x square equals to 4y in this equation and we will get values. So it is in the form of quadratic equation. Already we have solved this one also. So basic calculation is there here. If once we solve this, so what we get here, the point of intersection we get here, that is root 2 by 1 by 2 and root 3 by 2, sorry 3 by 2 comma 0, right? So let's see. Solve the given equation of a circle, that is 4x square plus 4y equals to 9 and the parabola x square equals to 4y. Then we obtain the point of intersection, right? That is b equals to root 2 comma 1 by 2. Just you can substitute the value in this equation and simplify. You will get the point of intersection root 2 comma 1 by 2 and the d value is minus root 2 comma 1 by 2. So it can be observed that the required area is symmetrical about what? Y axis. So now the area of OBCDO, OBCDO, this area, OBCDO, right, which is equals to 2 times of OBCO, OBCO, 2 times of this, right? So we are finding this area, the whole area we are finding here. So total this much area we are finding here minus this area. So what we get? This first one, this area we get. If multiply by 2, then we get this area also, right? So let's see, we draw PM perpendicular to OA. So we have taken here M, right? So PM perpendicular to OA. So therefore the coordinates of M are root 2 comma 0, right? Already we have got root 2 value. So therefore the area OBCO, which is equal to, let's see once, the area OBCO, OBCO, right? This much area, the whole area is like this. This much area we are taking here, right? So circle is moving like this. So only this much area we are considering here. So it is nothing but O. So this is circle OBCO, OBCO, which is equals to area of OMBCO. It is what? OMBCO minus of OMBO. OMBO. This whole term minus this term, right? So what we get here? Therefore, the area OBCO, which is equals to area OMBCO minus area OMBO, right? So just taking the values here, 0 to 2 limit under root of 9 minus 4x square by 2 dx minus of, here root is not there, only it is x square by 4, right? So 1 by 2 taking outside, 4 when commits from root outside becomes 1 by 2. So inside what we get? 9 minus 4 x square dx, 1 by 4 outside, inside x square dx, right? So 1 by, so now it is converting it is in the form of a square minus x square form. So again simplifying a square minus x square form, a square minus x square form. So we get the value is nothing but a square minus x square value is, yes, the formula is under root of a square minus x square, right? It is x by 2, what we have here, x by 2 under root of a square minus x square plus a square by 2 sine inverse x by a form, right? So just substitute in the form of x by 2 so just integrating what we get here, under root of 9 minus 4x square is there, so it is x under root of 9 minus 4x square plus 9 by 2, that is 3 square. A square means 3 square, it is 3 square by 2 plus sine inverse x by a, x means here 2x, 2x square means 4x square, x by a means it is 3, right? So minus 1 by 4 as it is, integration of x square is x cube by 3, limit 0 to 2 as it is. So now substitute the upper limit minus lower limit here, 1 by 4 as it is, upper limit that is root 2, root 9 minus of root 2, square root get cancel, 4 to the 8, it is 9 minus 8 plus 9 by 2 sine inverse 2 root 2 by 3, minus 0 neglected here, whole term becomes 0 here, and here 1 by 12 taking outside 4 by 3. So here what we get? Root 2 whole cube. So simplifying this, root 2 by 4 plus 9 by 8, just multiply 4 inside here. Sine inverse 2 root 2 by 3 minus root 2 by 6. So simplifying root 2 by 4 and minus root 2 by 6 we get root 2 by 12 plus 9 by 8 sine inverse 2 root 2 by 3 as it is. So finally by taking 1 by 2 outside, root 2 by 6 plus 4 by 9, 9 by 4 sine inverse 2 root 2 by 3. So therefore the required area OBCDO, it is OBCDO is 2 times of, just multiply by 2 the whole term, that is 2 to get cancelled here, the remaining value is root 2 by 6 plus 9 by 4 sine inverse 2 root 2 by 3 square units, right? So it is our nothing but the area of OBCDO. So next moving to the second question, very simple questions are there. If you get the logic or the concept, if you understand once, means it is quite easy to solve, only the integration part is there, basic calculation. So to find the area bounded by the curve x minus 1 whole square plus y square equals to 1 and x square plus y square equals to 1. Two circles are there here. So let's see the area bounded by the curve x minus 1 whole y square equals to 1 and x square plus y square equals to 1 is represented by the shaded area. Let's see here. So both are the circles here. It is x minus 1 whole square plus y square equals to 1. It is x square plus y square equals to 1. So the shaded region what we are seeing in the figure, which is nothing but our what? The bounded region, this region. Right? So it is taken as O, C, B, a point of intersections. So on solving the equations x minus 1 whole square plus y square equals to 1 and x square plus y square equals to 1, we obtain the point of intersection, that is A and B. These points we are getting, that is 1 by 2 comma root 3 by 2, 1 by 2 comma minus root 3 by 2. Just simplify the values, we will get these point of intersections. So it can be observed that the required area is symmetrical about x-axis, right? So the area OBCAO, this reason we are seeing OBCAO, which is equals to 2 times of what? Area of OCAO, this reason, OCAO, right? So if we find this much area, means later on by multiplying we can find the whole reason here, right? So let's see. We join AB dotted line we have taken here, which intersect OC at M, this point, OC at M, such that AM is perpendicular to what? OC. So let's see the coordinates of M are 1 by 2 comma 0, that is 0.5 comma 0. So now the area OCAO, which is equals to area OMAO plus area MCAM, right? So just take limit 0 to 1 by 2 integration under root of 1 minus x minus 1 whole square dx plus root 1 minus x square dx, that is y dx, it is, right? Actually the values are what here? 0 to 1 by 2 y dx plus 1 by 2 to 1 y dx, right? So now just we have taken the values. So integrating this term again, a square minus x square form. So x by 2 under root of a square minus x square plus a by 2 sine inverse x minus 1, it is, right? What we have the formula here again? A square minus x square formula is it is x by 2 under root of a square minus x square plus a square by 2 means it is 1 by 2 sine inverse x minus 1. X by a means again 1, x minus 1 by 1, it is neglected, right? So limit 0 to 1 by 2. And similarly here also it is a square minus x square, it is x by 2 1 minus x square plus 1 by 2 sine inverse x, limit 1 by 2 to 1. So now applying upper limit here, what we get? Minus 1 by 4 outside, 1 minus of value of x, what we get? 1 by 2. It is cross multiplies, what we get here? 1 minus 2. It is 2 to 4, that is minus 1 by 4 outside. So inside 1 minus of minus 1 by 2 plus 1 by 2 sine inverse 1 by 2 minus 1 minus 1 by 2, when you substitute the value 0, that is 1 by 2 sine inverse minus 1, it is, plus as it is. Now second term, applying upper limit, it is 1 by 2 sine inverse 1 minus 1 by 4 under root of 1 minus 1 by 2 whole square minus of 1 by 2 sine inverse 1 by 2, that is upper limit minus of lower limit. So on simplifying this, what we'll get here? It is root 3 by 8 plus 1 by 2 sine inverse 1 by 2 is minus 1 by 2 is minus pi by 6, that is minus 1 by 2 sine inverse minus 1 is minus pi by 2 plus as it is 1 by 2 sine inverse 1 is pi by 2 here, again minus root 3 by 8 we get here, my 1 by 2 as it is, sine inverse 1 by 2 is pi by 6. So simplify this, what we'll get? 2 pi by 6 minus root 3 by 4 is the required answer. next moving towards question number 3. So for the required area OBCAO, which is equals to 2 times of one part, we have got this much. So 2 part means which is equals to just multiply by 2. What we will get here, it is 2 pi by 3 minus root 3 by 2 square units is the required solution. So next, third problem. Find the area of a region bounded by the curve y equals to x square plus 2, y equals to x, and x equals to 0 to x equals to 3. So let's see. I will given values here. The bounded curves y equals to x square plus 2, y equals to x, and x equals to 0 to 3, represented by the shaded region OCBAO. Let's see in the figure. So we have drawn the figure y equals to x square plus 2, whereas the line y equals to x we have. So this shaded region we have to find here under the two curves. One line is there, one curve is there. So the area OCBAO, OCBAO, which is equals to the area ODBAO, ODBAO minus area ODCO. We are subtracting this area, right? So now integration 0 to 3 limit function we have common for both, x square plus 2, it is y dx again, minus 0 to 3 x dx, right? So integrating this x cube by 3 plus 2x 0 to 3 limit, again minus x cube by 2 0 to 3 limit. So on substituting upper limit, it is 9 plus 6 minus it is 9 by 2. So what we get here, 15 minus 9 by 2 means it is 21 by 2 square units is the required area. So next, question number 4. Using integration, find the area of a region bounded by the triangle whose vertices are minus 1, 0, 1, 3 and 3, 2. Three angles vertices has been given of a triangle. So let's see, they are asking to find the area of a region bounded by the triangle. So let's see, we have a triangle C. So BL and CM are drawn perpendicular to x-axis. BL and CM are drawn perpendicular to x-axis. We have plotted the graph by using the vertices. So when we are taking perpendicular, BL is perpendicular and CM is perpendicular to x. And it can be observed that the following figure that the area of a triangle ACB, which is equals to area of a triangle, what they are saying, area of a triangle ACB, which is equals to area ALBA plus area BLMCB minus of area AMCA. Let's see. Sorry. The area ACB we have, right? So which is equals to the shaded region we have ACB, which is equals to area ALBA, right, plus area BLMCB minus of AMCA, right? So this much whole area, this area, they are saying first this area plus of this area minus of this area, right? So let's see, the equation of a line segment AB is y minus 0, that is already you know the formula, equation of a line segment, that is y minus y1 minus x2 minus x1 upon y2 minus y1 into y minus y1, right? So x minus x1. So y minus, the values are already given, it is 0, 3 minus 0, that is 1 plus 1, x plus 1. So y value what we are getting here, 3 by 2 x plus 1. The equation of a line segment AB we are getting here. So the area ALBA, this reason, first reason we are finding here. So it is equals to limit minus 1 to plus 1, right? So x value minus 1 to plus 1, 3 by 2 x plus 1 dx. So 3 by 2 taking outside, integrated x square by 2 plus x minus 1 to 1. 3 by 2 as it is, applying upper limit minus lower limit, what we get here, 3 units is the area of ALBA. So the equation of a line segment BC now, this line. So y minus 3, 2 minus 3 by 3 minus 1, just we are substituting value x minus 1. So y equals to 1 by 2 minus of x plus 7, right? So area of BLMCB, which is equals to 1 to 3 x axis, that is 1 by 2 minus x plus 7. 1 by 2 take outside is minus x square by 2 plus 7x. 1 to 3, applying the limit here, what we get, 5 units. So equation of a line segment AC finally. So which is equals to y minus 0, that is 2 minus 0 by 3 plus 1, that is x plus 1, that is y equals to 1 by 2 x plus 1 we get here, line segment AC. So just substitute the value here, what we get, y minus x1 y1 x2 y2 x3 y3. So AB means x1 y1 x2 y2. So it is y minus y1 is 0 minus x2 minus x1, it is 3 minus 0 by 1 plus 1 into x minus of x1. x1 is minus 1, it is plus 1, right? So already we have the formula y minus y1 upon, it is y2 minus of y1 upon x2 minus x1 into x minus of x1. So just simplifying this again, the area AMCA 1 by 2, that is minus 1 to 3 x plus 1. So 1 by 2 outside, x square by 2 plus x minus 1 to 3, by substituting the limit function we get 4 units. Therefore, from the equation 1 we obtain the area of a triangle 3 plus 5 minus 4 is 4 units. So next, moving to question number 5. Using integration, find the area of a triangle region whose sides have the equation y equals to 2x plus 1 and y equals to 3x plus 1 and x equals to 4. So let's see the equation of sides of a triangle given right down as it is. So on solving these equations, we obtain the vertices of a triangle A equals to 0, 1, B equals to 4, 3 and C equals to 4, 9. So you can take all the three equations and simplify it, basic calculation by substitution method, by cancellation method, you can take any method, solve these equations and you will get these triangle vertices. It is A, B, C. It is A 0, 1, B 4, 12 and C 4, 9. So by taking these values, we plot the triangle here, graph. So it can be observed that the area of a triangle ACB, which is equal to, it is a shaded region, right? You have to find this region only. So the area OLBAO, this is area of y equals to 3x plus 1 minus, which is equals to OLBAO minus area of OLCAO, this region. The shaded region what we are finding here, that is triangle ACB. So let's see the integration 0 to 4 y dx, it is 3x plus 1 dx minus again 0 to 4 2x plus 1 dx. So now integrating this, what we get is 3x square by 2 plus x, 0 to 4 minus 2x square by 2 plus x, 0 to 4. So just substitute upper limit here, 24 plus 4 minus 16 plus 4, which is equals to 28 minus 20. We get 8 square units is the required area of a triangle ACB. So next question number 6 is an objective type question is there. Smaller area enclosed by the circle x square plus y square equals to 4 and the line x plus y equals to 2, where a value is 2 pi minus 2, pi minus 2, 2 pi minus 1, 2 times of pi minus 2. So let's see. The smaller area enclosed by the circle x square plus y square equals to 4 and the line x plus y equals to 2 is represented by the shaded area A, C, B, O, ACBA, ACBA, this is ACBA, right? ACBA, as it can be observed that the area ACBA, which is equals to area OACBO, OACBO, this whole area we are considering, right? This whole area minus of the area of a triangle OAB, right? This area we are subtracting. So let's see. Integration 0 to 2 under root of 4 minus x square dx and 2 minus x. So again it is in the form of under root of a square minus x square. So already we know the formula for that. A square minus x square formula is x by 2 under root of a square minus x square plus a square by 2 sine inverse x by a, right? So similarly substitute the value here, and similarly here also 2x minus x square by 2 integration 0 to 2. So applying upper limit here, what we get? This term neglected, 0. So 4 by 2 it is 2 sine inverse pi by 2, that is 2 by 2 is 1, sine inverse 1 is pi by 2, it is 2 pi by 2 minus, applying upper limit is 4 minus 2, the value what we get here, 2 to get cancelled, it is 4 minus pi minus 2 is the required answer. So thus the correct answer is what here? The correct answer is B is the right answer. So next, finally, 7th question and last question of this chapter. It is area lying between the curve y square equals to 4x and y equals to 2x is A equals to 2 by 3, B equals to 1 by 3, C equals to 1 by 4 and D equals to 3 by 4. So the answer, let's see. The area lying between the curve y square equals to 4x and y equals to 2x we have here, let's see, is represented by the shaded area OBAO. OBAO, this reason, right? So simplifying these two equations, we get the point of intersection is 1 by 2 and 1 comma 0, and we are taking AC perpendicular to x-axis. So the point of intersection of these curves are 0, 0, A 1 by 2, and we draw AC perpendicular to x-axis and the coordinate of CR 1, 0, already we know that. So the area OBAO, which is equals to area of a triangle OCA minus of OCABO, right? So now take the values here, integration 0 to 1 2x dx minus 0 to 1 2 root x dx. So 2 taking outside, integration of x is x square by 2, limit 0 to 1, minus 2 outside, integration of root x is x to the power of 3 by 2 by 2, 0 to 1. So simplifying this 2 to get cancelled, upper limit is 1 here, minus, again it becomes 4 by 3, 1 means 1 to the power of 3 by t is 1 only, so it is 4 by 1 minus 4 by 3 is my 3 1 3, 3 minus 4 is minus 1 by 3. By applying what we are getting here, positive 1 by 3. So the correct answer is B. So therefore the answer is B. Answer B is 1 by 3 is the required solution. So with this we will conclude our today's lecture and as well as the chapter application of integrals. So go through once again application of integrals. If you have any problems with respect to any example, then you can ask without any hesitation at any time, right? So Work hard. Very easy chapter is there. If once you understand the concept, so you can solve any kind of a problem here. So do practice more. In mathematics, usually we say practice make man perfect. So if you practice more means you can perfect yourself. So no need of any guide, teacher here. So practice is a major thing here. If you have any doubts, then also we are ready for you. So please go for it, and we are always with you. So with this, we'll conclude our today's lecture here only. In the next lecture, our final chapter left in our syllabus, that is probability. It is also very important chapter and very wide one and very logic also. So you have to think there logically. The questions are twisted questions are there. So we will see in the next lecture. Probability, already you are familiar with the probability in the first year, 11th standard you have studied the probability introduction part. So let's see how much you remembered 11th syllabus when we start our 12th probability. So we'll see one by one. So till then, take care, stay at home.